Hello everyone, I am Ikram Kaadoud and I am postdoc working on Explainable AI with my supervisors, Lina, Fahed and Philippe Lenca. We are part of the DECIDE research team attached to both the French National Center for Scientific Research, also known as CNRS, and the IMT Engineering School in the city of Brest, which belongs to the region of Bretagne in France. Today, the title of my talk is Explainable AI, a narrative review at the crossroads of knowledge discovery, knowledge representation, and representation learning. To begin with, I would like to give a few details about this presentation. This is not a technical presentation of results, nor a review of existing explainable AI techniques. This presentation, and by extension, the paper related to it, is a review of the literature that synthesizes technical research works related to domains that implicitly inspire explainable AI. This work results from several discussions about the explainability of AI models within my team, composed of researchers with different backgrounds. So through this work, we hope to offer an entry point to the domain of explainable AI for both multidisciplinary researchers, but also specialists in AI, as well for AI knowledgeable users. We hope to bring thus original insight, formulate new research questions, and highlight promising future work in explainable AI. So today's talk will be in three parts. First, an introduction of the concept of explainable AI. Then second, I will present the main idea behind knowledge discovery process, knowledge representation, and representation learning, but also how can they be useful for explainable AI. Finally, we will end by a discussion about explainable AI and knowledge. So let's start with the question, what is explainable AI? One accepted definition today in the literature is the one that said that an explainable model is the one that, given a target audience, produces detail and reasons to make it functioning clear and easy to understand. And there are two ways to do that. First, by directly design explainable models and results. And second, by making AI models more intelligible and accessible. In other words, for a given question about an AI model, mechanism and results, an explainable AI process will provide an explanation to a target audience. Explainable AI, as AI in general, is a topic that involves many research fields, such as cognitive science, social science, ethics and fairness, and of course, computer science. But which is important to highlight is that explainable AI is a topic that goes beyond the machine learning and deep learning fields. It can concern multi-agent system, computer vision, game theory, robotic, knowledge representation and reasoning, and also other fields. When it comes to explain an AI model, an important question is, what do we want to explain? Indeed, there are many dimensions in an explainable AI model to explain. Is it a particular prediction that we want to explain? Is it the impact of data feature on a particular task? Or maybe it is the model and its inner mechanism by itself that we want to explain. This last question can be indeed very difficult to deal with when according the type of model we are considering. If they are already transparent model, we can cite, for example, linear regressions or decision trees. We will use what we call ad hoc explainable AI techniques. These techniques consist in optimizing an already transparent AI model by adding constraints or features in order to increase transparency through metrics, and data visualization, for example. If the models we're considering are not transparent by design, for example, deep neural networks that are well known for their inner opacity and complexity, we will use post-hoc explainable AI techniques. This technique can be used to add an additional layer of techniques in order to explain the original model. Another question that is important to answer is, to whom do we want to explain? In a process of conception or simply use of an AI system, explainable AI can address and involve different actors who have different roles. We can think of, first of all, the user affected by the model, but we can also think of the managers and executive board and decision maker who do not necessarily have a technical profile, but who play a macro role on projects. Of course, we can also think about the domain experts that are going to use the model, or the regulatory entities and agencies that need to certify them. And last but not least, there is the technical community, the scientific community, us, that are also important to think about. So, an important point to highlight here is the importance of cognitive science when it comes to the target audience question, because we all want a more inclusive, responsible AI world. So it means that explainable AI should include everyone and independently of their, everyone and anyone independently of their cognitive profiles. So this is why cognitive science is a big part of explainable AI. Let's recall now that explainable AI purpose is to provide an explanation of the internal mechanism and the reason behind an AI model behavior. So we can consider an explanation as an interface between the AI model from one hand and the target audience from the other hand. But more concretely, what is an explanation? An explanation is an information in a semantically complete format, which is self-sufficient and chosen according to the target audience regarding its knowledge, expectation, and the context. An explanation is contextual by its very nature. It's specific to a given target audience and context. This makes explainable AI more challenging, as automatic context understanding is still a very challenging task, and there is no unified way for modeling context in intelligent environments that have been proposed or majoritarily adopted in the literature. Finally, an explanation can align multiple forms and or representation, like, for example, text and visual explanations. To summarize, we can say that explainable AI can address a variety of different kinds of persons. Everyone and anyone can be targeted by an explanation. Explainable AI should thus be able to deal with these different profiles. This leads to many technical challenges, as we cited before. And one interesting point in explainable AI is the place of knowledge in the field. As an interface between an IA and a target audience, an explanation can be thus considered as a kind of interpreter between an IA knowledge and the human target audience knowledge. Thus, explainable AI can be resumed to two questions. How can we discover new or retrieve existing knowledge? And second, how to represent the knowledge for target audience? If the term explainable AI has been recently proposed, artificial intelligence models with explanation goals have been questioned and investigated for a long time ago. There are indeed conferences, journals, workshops dedicated to these questions. And since knowledge is a domain historical in AI, this raises in turn important questions about the impact of domains such as knowledge discovery process, knowledge representation on explainable AI. And on top of that, if we consider that regarding black box model and especially neural network, since in recent paper, concepts like representation learning, latent representation, hidden, abstract representation, latent space, all these concepts have been regularly used to explain this black box question. Well, this also questions the position and the impact of the field of representation learning in explainable AI. And this is exactly what we are going to discuss in the next section. When it comes to the subject of knowledge discovery, the first related field that we can think of is knowledge discovery process. This process can be used to discover first new valid and useful knowledge with respect to the data, but it can also be used to retrieve existing knowledge for user hypothesis verification. This process consists in processing data, such as text, image, for example, in order to extract information that is evaluated by humans. This field target audience can be, for example, application domain expert and decision maker, which make it human-centered. In explainable AI, for black box like deep neural networks, technical approaches are used to source information from data related to the behavior of an AI model. Explaining an AI model is therefore very inspired from knowledge discovery process. The particular point here is that in explainable AI, the input data is related to the black box AI model. It can be of several types, such as an activation patterns of hidden layer, features, or even representation. And sometimes it can require the same techniques as in knowledge discovery process. Knowledge discovery process is thus essential to consider for explainable AI modeling. It provides proven toolbox and processes to extract knowledge from data. Knowledge representation is a crucial question in AI. These fields aim at finding a way to efficiently structure specific domain knowledge for automated reasoning, but in a human readable way. It is closely related to the concept of ontology, and many knowledge representation techniques are already popular in the field, like semantic network and semantic web. The purpose of knowledge representation is to allow intelligent machine to learn, draw inference, make decisions, and answer questions related to this knowledge. It is thus both at the same time a human-oriented and human-centered domain. Let's note that the development of deep learning these recent past years has blurred the boundaries between knowledge representation and representation learning that we will discuss later. Indeed, there is a field known as knowledge representation learning, which is a whole field dedicated to the process of making neural network learn structural representation of a domain-specific knowledge. As the consequences, concepts, for example, relation between them and their representation can be encoded in low-dimensional semantic space, which allow to use other techniques than just graph mining techniques. So, present and past work in knowledge representation and knowledge representation domain are thus essential to consider for explainable AI, since they already have been dealing with the question of efficient knowledge representation and the trade-off between machine performance and humans' intelligibility. Finally, there is the field of representation learning that is related to the field of machine learning algorithm. It is defined in the literature as the field that focuses on learning representation of the data that make it easier to extract useful information when building classifier and or other predictors. In other words, representation learning focuses on learning abstract features that characterize data representation as learned by the model. So, according to this definition, here for representation learning, the word representation means here a set of features that express priors about the data learned into the latent space of a neural network. And this is important because in deep learning algorithms, it has been shown that hidden representation tend to keep dominant information and to propagate them across hidden layer regardless the width and the depth of deep neural network. This means that potentially by extracting and comparing the low-level representation and the high-level representation of a deep architecture, it is possible to explicit the inner mechanism of the architecture by observing the difference between these representations. This field is completely machine-oriented since the representation are not human-readable. It takes post-hoc technique usually to extract and interpret these hidden representations. Since representation learning is a popular field, there are already many great works in different domains of AI that we can, as explainable AI researcher, get inspiration from or use in order to advance our research. Representation learning and explainable AI in explainable AI is thus essential to consider, especially when it comes to explaining deep neural network, because it allows to study and to propose model-specific explainable AI approaches. To summarize, when it comes to the question of how to discover and represent knowledge in AI models, there are already fields that have investigated this question and that we should definitely take into account when it comes to the conception of explainable AI models. To conclude this presentation, here are some points that I would like to highlight and to discuss. We just saw that explainable AI is a very exciting but also very vast domain. Explainable AI's goal is to convey the most semantically complete explanation to a target audience in order to answer a particular question within a given context. As we saw previously, as an interface between an IA model and target audience, an explanation can be considered as an interpreter between the IA knowledge and the IA model knowledge and the human target audience knowledge. So this explanation should take into account two important points: the prior knowledge of the target audience regarding its application context, its own context, and the tools, the technical aspect of the IA used and question model. This leads us in my team to consider that explainable AI is about knowledge discovery and representation. This is why we discuss explainable AI from a technical perspective at the crossroad of knowledge discovery process, knowledge representation, and representation learning domain. These fields, while distinct, are overlapped. The current work and past ones do and should have an implicit impact on explainable AI approaches development. Let's recall that first, knowledge discovery and representation both tends to express information from data, so explainable AI approaches would certainly benefit by getting inspiration from this field. However, it is important to underline that in explainable AI, the input data reflect the internal mechanism of the AI model, its prediction, and its behavior. The evolution of the knowledge domain at large is therefore an inspiration area for explainable AI. Second, as we said previously, the development of AI approaches, and in particular of deep learning, has blurred the boundary between knowledge representation and representation learning. Since several knowledge representation approaches involve representation learning and deep learning. We can recall also that while representation learning is interested in feature modeling for algorithmic issues like performance dimensionality, explainable AI is interested in features since it contributes to explicit the inner mechanism behind the results. This implies that representation learning, knowledge representation, and explainable AI are all interested in the data representation in order to answer different but related questions. Third and final point, knowledge discovery process, knowledge representation, and representation learning have been extensively confronted with, from one hand, issues related to providing a data-driven explanation to different stakeholders according to the expectation and context, and from the other hand, to the question of biases in data and AI. This highlights that the human significant role on data processing and bias detection in AI towards explainable AI. This is why, to conclude, we would like to point out that other domains not discussed today are also important to consider since they are going to impact explainable AI directions. We can cite, for example, cognitive psychology, cognitive science for bias studies, social science, and also human interaction field. So it seems that the most exciting part seems ahead of us. Thank you for your attention.